Right here, I want to give you a hint how to solve this problem. So first, you will need to build a relationship between VB and VA. That's block B and block A. If you look at B and A is at both ends of this rigid bar AB. Then we can actually use the instance center method from chapter 2 to analyze this rigid bar AB. So if we have this AB, we know the direction of velocity at point A goes down and the velocity at point B goes to the right. Therefore, we can draw two perpendicular lines to those two velocities. Then we have this intersection O, which is the instance center of this bar AB. Once we know the instance center, we were able to use the equation of VA equals omega times LOB, which is the angular velocity of the bar AB times the distance from the instance center to the point A. Similarly, we can find expression for VB equals omega times LOB. Then I can find expression for omega by using VB. Omega equals VB over LOB. And I can resubstitute this omega into VA to find expression with both VA and VB inside. So VA equals VB over LOB times LOA. And if in this case LOB is given in the problem, LOA is the distance from O to LOB, O to B, that is given as H2. So we can write LOB as H2. And LOA can be solved by using triangle, right triangle, which equals to square root L squared minus H2 squared. Then substitute LOA into the expression. You get an expression for VA equals VB over H2 times square root L squared minus H2 squared. And you were able to use this expression. This will give you one more equation, help you solve the speed at point B at position